In this video, we're going to discuss questions regarding double slit experiment tutorial. Let's go. In double slit experiment, a monochromatic light produces interference fringes that's shown on two slits separated by 0.3 millimeters. So this is a small d. The screen is placed 1.8 meters away. So this is capital D. The fourth bright fringe is observed at a distance of 14.4 millimeters from the central bright fringe. Calculate the wavelength of the light. Fourth bright fringe is fourth order. We're going to use the equation of ym equals to m lambda d over d because we're looking for bright fringe. So to get better understanding, this is our central bright, 0th order, and this is our fourth order. The distance of 14.4 millimeters is from the center of the central bright to the fourth order of the bright fringe. We substitute. Here we have the order 4, the distance from the central bright to the fourth order of bright fringe, and then the capital D and the small d, and then the answer is 600 nanometers. Question B, asking for the fringe separation. If you look at our note, fringe separation is basically fringe spacing. So delta y equals to lambda d over d. And then we just substitute the lambda, the d, and also the slit separation. And the answer is 3.6 millimeters. For question C, the distance between the second dark fringe and the center bright fringe. So first of all, we're gonna determine what is the order. The second order dark fringe is M1. Remember that you tolak satu sebab the first dark fringe is 0th order, right? So untuk dia kata second dark fringe, so that's basically first order lah. Okay, and the equation that we're going to use is y1 sebab first order equals to 1 plus half lambda d over d. You see here we have central bright and then we go to the first order. So this is y1 dark fringe lah basically. What I did here, I used 3.6 times 10 to the power negative 3. What is this? This is actually this part. Yang ini sebenarnya ialah delta y kalau you perasan. Saya just ambil value yang lambda d over d, saya bawa masuk dekat dalam ni. So I put it back into here and then saya tinggal darabkan dengan 1.5. And for that, the answer is 5.4 millimeters. Alright, let's move to question number 2. In a double slit experiment, monochromatic light of wavelength 520 nanometer is used. The slit separation is 0.25 millimeters, so this is that. The screen is placed at 2 meters away. Determine the distance between the fifth dark fringe, so m equals to 4, I believe, and then the fifth bright fringe, so this is just m equals to 5, like that. So we have to calculate the distance between those two. Okay, so fifth dark fringe, as I said, is fourth order. And then we're going to use for dark fringe equation, y4 equals to 4 plus half times lambda d over d. Notice that I didn't do anything. Saya just biarkan dia dalam bentuk ini sebab later on baru saya nak tolak. Baru saya masukkan value lambda d dengan d ni semua. Sebab saya tahu ini ialah apparatus yang sama, setup yang sama. So, kendian baru saya tolakkan. Okay, sekarang ni kita pergi kepada fifth bright fringe. Fifth bright fringe sama fifth order. Dan equation yang kita guna yang tak ada plus half tu. Beza antara dua, satu dark, satu bright yang bersebelahan tu. Okay, kita masukkan value. Kalau you tengok kat sini, 5 tolak dengan 4.5 dapat 0.5. And then saya terus masukkanlah yang lambda. Lepas tu ni ada D besar. And then yang ini ialah D kecil. Can you see that? So jawapan dia ialah 2.08 millimeters. Kalau you nak buat cara lain yang lebih mudah. Okay, the question is asking for distance between the fifth dark fringe, which is M4, yang ini. And the fifth bright fringe, of which is m equals to 5, which is this one. If this one is delta y, for sure lah, this one is half of the delta y itself. You know what I mean? So you just get the delta y first, which is 0.00416 meters, and then you buat apa? You just bagi 2 je, babe. Okay, so this distance between them, you bagi 2, then you're going to get the same answer. Let's move to question number 3. Two monochromatic lights are used simultaneously. Sebelum ni, dua example sebelum ni kita pakai satu je monochromatic light, but this time kita pakai 2 monochromatic light. And then dia kata, if the second bright fringe of the red color is coincide, misalnya bertindih antara warna, whatever warna yang kita tak tahu tu, dengan the other one, which is the merah color, with the third bright fringe of the unknown light, determine its wavelength. We're going to start with y of the second order of the red color equals to y of the third order of the unknown light. The third bright fringe, so the third order lah, senang je. So we just use the equation, boleh potong. Dan kita tinggal masukkan je value, and your lambda untuk unknown color is 433 nanometer. And the last question, a monochromatic light of wavelength 500 nanometer is used in Young's double slit experiment. The slit separation is 0.3 millimeters and the screen is 2.4 meters away. Calculate the change in the fringe spacing when the slit separation is halved. So kita buat dulu ungkapan algebra dia. So D yang baru sama dengan setengah daripada D yang asal, and then because this is a fringe separation, so we're just going to use delta Y equals to lambda D over D. And then from here we got the 4.8 millimeters ni. This is the original before kita separuhkan dia, and then we use this one to get the half, and then so the answer is 9.6 millimeters. And why do we have to do this? Sebab dia minta the change, how much daripada asal ke yang baru tu, berapa banyak beza dia tu. So and for that kita tolak the change in the delta Y is 9.6 minus 4.8, which is the original. This is the new, and the answer is 4.8 millimeters.